Hello, everyone. I'm Giulia Scagliotti, a PhD student at SciFi. Over the last 2 years, I've been working at the intersection between industrialized construction and sustainability and circularity. I've studied IC companies both in Europe and in the United States, and conducted 2 case studies, one with an IC in Sweden and one with an IC company in the Bay Area. So today, I'm happy to share with you the key insights that I gained through these experiences. Unfortunately, this is what's happening right now. This is typically what's happening at the end of life of our buildings. We demolish them. 540 million tons of demolition debris are generated each year in the United States. The embodied carbon in this debris is at least equivalent to the embodied carbon generated by all the people in California to live 1 year. It's huge. We definitely do something wrong, and we need a change. If we think about design, we expect our buildings to live about 50 years or more. This is the typical design life. But we discover that, especially in some countries, the effective life of the buildings is much shorter. Buildings are demolished after 20 years or 30 years. And if we look at reasons behind demolition, the building demolished are typically still structurally sound. Only out of many buildings demolished, only 3% of them show some structural problems. Many times we demolish buildings because we would like to change, do some redevelopment in the area they are located in, or because they are no longer suitable for our needs. So in summary, we demolish buildings that are still relatively young and structurally sound. And unfortunately, materials and components from these demolished buildings goes in the landfill, where we would like to avoid to place in the landfill and possibly recycle materials, reuse materials and components to make new buildings, and ideally reduce the amount of new buildings and extract raw materials. So what we need to do is making a shift from a linear process in which we extract material, we construct buildings, we use it, we demolish it, towards a more circular process in which we adapt possibly many times the building. And in case we don't need them anymore, it would be possible to disassemble them, deconstruct, and then in a very organized way, reorganize and reuse those materials. And industrialized construction, I think, is the best strategies available nowadays that can bring circularity to our industry. And in this talk, I will talk about on why and how we can do that. So first of all, we need to go back to the early design stage. Because 80% of the environmental impact of a product is influenced by decision that we are making at the early stage of design. Early stage is very critical, and we would like to put our project on a good track. So in a project-based approach, a traditional approach, we start with project 1, and we try to design a more adaptable building, more disassembled. We think about materials and technical systems to use. We complete the project, and then we move to project 2, and we need to do it again. And this is happening again for project 3, 4, and 5. And it's very difficult to achieve any consistency in improving sustainability and circularity of our buildings. So industrialized construction has advantages. Yes, the project will slightly differ. They have variations, but overall, we can work with technical systems. We can possibly repeat the same technical systems over and over. And then we work also with product platform that help us to configure a building and pick about different options, but a limited number of options still. So to avoid this huge amount of waste that we generate, disassembly is essential. And without disassembly, we wouldn't have circularity. So let's dive in. So to ease disassembly, we can divide our product into different technical systems. So we have the site in which the building is located, but then we have the structure that hopefully lasts more than 50 years, and then other technical systems that have a shorter lifespan. We would need to divide technical system with different lifespan. We have skin, so facade, envelope, and roof, and also services, which include MEP. Those technical systems, likely we would need to repair them, to assess them, to maintain them, and also substitute them over the life of the building. So that's very important, that their life is shorter than the structure, than the one that the structure. And then also space span, internal walls, and furniture and appliance with even a shorter life. So these are the technical system I'm referring to. So, and when I looked at case studies, I realized we are not always keeping the technical system separated. In particular, the way MEP systems are designed does not favor an easy disassembly. So as you can see, this pipe is embedded in the structural system. If I need to repair, substitute that, move it, it's really challenging. So, but we have also good examples from practice. This is a good part of MEP system that is easily accessible from a terrace. And this is a great example of very easily assembled and disassembled MEP. If we zoom out, so we see that the connection is based on a plug-and-play system, really easy to assemble and disassemble. So, and when we look at disassembly, we also care about connection, and if they are wet or dry. In this case, we have a not detachable brick facade. The facade is connected through wet connection to the structural wall, so not easily detachable. Here we have a wood cladding facade, which is attached through dry connection, so easily detachable. And it seems we identified some technical system that may work, but however, from interviews that I found that IC companies are aware about this, design for disassembly, but not always are interested in. Company one shared with me that they are making long-lasting buildings, and they are not dealing with disassembly. Second company didn't have disassembly among their priorities. Third company was very convinced to have a product that can be disassembled, but they never tried to disassemble one. And other companies needed to disassemble their buildings because they make some mistake during the construction. And they shared with me that it was very, very challenging to disassemble their product. And that's because it wasn't designed for disassembly. So disassembly should really need to be considered from the early stage, even if it will occur far in the future. So how can we plan disassembly? First, workers need to carefully follow some instruction without adding extra nails or extra elements during construction. We should avoid wet connection where possible and favor dry connection, and also placing those technical systems with a shorter life in a way they are accessible. A solution that some Swedish companies found are developing guidelines for disassembly, in which they list all the steps they need to do to complete a disassembly project. They elaborate instructions, put images, and also the equipment needed to complete their disassembly. And if during disassembly they encounter some problems, it would be very helpful to keep track of those problems and fix the product to increase, and a continuous effort to improve their product and increase the disassembly potential. So we know that we don't have only technical system, we also have product platform. They collect already the technical system and the elements within the technical system, but it would be very helpful to also model the interfaces, the connection, the type of connection, the material the connection are made of, the relationship between technical systems and elements, so we would know how a facade is connected to walls and so on. And this is how a product platform that model also interface would look like. And we have product platform in which we have distinct technical systems. We could add also a lot of information. The lifespan of each system, the materials they are made of, the quantity of material, the expected end-of-life treatment, if they are going to be reused or recycled or downcycled, and the expected value those material or those systems can have. And compared to material system can have a higher expected value. So we basically are building a material and system passport in which we see the building as a temporary depository of material. But we know that there is not only sustainability. There are so many other needs and interests. So obviously also the cost. We are interested in the initial cost of our product, the time in which we complete a project, eventually if we care about circularity, also the disassembly time, the quality of the product in terms of durability of their material and the systems, the suppliers, our relationship with them and the reliability of suppliers, and also some project specifics, and many other more variables. And obviously we need to comply. We must comply with certain regulation. These are all important, and we can look at other industry, how they look at the problem. Some of them adopt design for excellence, which is a concurrent engineering philosophy, in which X can be, is a variable that can have many values. And the furniture company IKEA is adopting these strategies and is selecting 5 core values, which are sustainability, form, function, quality, and low cost, low price. And they try to make those 5 core values working together. And actually, industrialized construction, compared to a traditional approach, project-based approach, has better opportunities to select the core values they are interested in and make them working together. So we are not yet there, but we can get. And sustainability team should not be left alone in this journey. I can share a story from one of my case studies. I went to the sustainability team, and they were very, very excited because they found a new supplier that could provide a steel with a lower embodied carbon. So they wanted to buy that. And, but there are other departments. And I went to purchasing team, and they were not aware about that specific supplier. And they found that the material was too expensive. And then I went to supply chain, and since this company was building, their main material was steel, they say that they can't rely only on one supplier because they needed many suppliers to lower supply chain risk. So from this example, you can see the many interests and the many variables that play a role in final decision. And only with synergy within an IC company, we would achieve better results and a more circular final product. And this is not only applying within the IC company, but also externally with our stakeholders. I see this is emerging in Northern Europe, in which we try to build supporting networks, in which all the stakeholders take a part to move forward in this circularity. And it's not only about suppliers that are starting providing more EPDs and have more transparency about their product, but also about customers that start to require more sustainability for their product. And also financial institutions that are starting to offer better loans to sustainable projects. And insurance companies that are trying to provide insurance to buildings that are made out of reused materials. And I think also research university can play a role. And certainly at SciFi, we are willing to continue to learn from each other and do our part and continue to learn with from each other and collaborate to bring circularity with industrialized construction method to our construction industry. Thank you so much for your attention, and I'm happy to talk more.